So, okay, good morning, class. I want to make sure that we are covering a couple of important properties today, okay? The first property I want to cover with you today is called the, have you ever heard of this? Inverse property? Okay. Have you ever heard of identity property?
Yes.
Good. What about equality property? Okay, some of you have heard it, some have not. Fine. What about property of zero? What does it mean? Oh, let's take a look at this. So the first property I want to show you today is called the identity property. Okay? Okay, for identity property we have two branches for that, and the first branch here is called additive. So we put together and call it additive identity property. So it's that term. I need you to memorize that. And the other branch is called the multiplicative. Okay, so just like its name, additive means addition and multiplicative means multiplication. Good. So for additive, identity, can you give me an exact definition of identity, please? What does it mean to have an identity? Yes. Okay, well actually, I hope you remember this. Identity, just remember this as identical. Okay, just remember that. So whatever you do, for addition, you should get that same value after you add it. So for instance, if I give you a 6, what should you add to that 6 to get back a 6?
0.
A 0. So there you have it. We call it this an additive identity. And it will stay in this format always. So whatever number I give you, added to 0 will always give you that same number back. Please don't think that because I have a 0 here, we have a 0, you reinvent a name and call it the 0 additive identity, property. That's not the case, right? This is additive identity. That means you start with some number, you always end up with that same number after adding a 0. Okay? Likewise over here, for multiplicative identity, if you take a number, for example, what do you have to times it by to get back that same number? Yes? 1. You see that? So if you take A, times it by 1, you still get back an A. Okay, so is that hard to understand?
No.
For multiplicative identity or additive identity. Please understand it. Please memorize the format so that when you see it in action, you should recognize it and be able to label it right away. No question about it, right? Okay, good. Next one. I want to introduce to you something called the multiplicative property of 0. Well, can't spell, sorry guys. I'm just going to prop for a property of 0. Or we can also call this the 0 product property too. So it has two names. Either way is fine. Notice it's pretty much the same. Product means multiply, right? 0, you already have that, so it's the same stuff. But I just kind of switch the terms around. So I have two ways of saying this same property, and it means this. If you take a 5 times 0, what do you get back?
0.
A 0. Whoa, who said 5? 0. If you take 10,000 times it by 0, what do you get back?
0.
0. If you take anything times 0, what do you get back?
0.
Okay, therefore we have something called the multiplicative property of 0. And it only applies to multiplication. Is that clear? Good. All right, moving on. That's not too bad, right? Okay. Here's another one I want to introduce you here to. It's called inverse. And inverse, once again, has two branches. The first branch is additive, just like the other one. And the other one is called the, what do you think? Multiplicative. Very good. Okay. Additive inverse is basically finding its opposite of the number. So watch what happened. What's the opposite of 5? Negative 5. So if you take 5, add it to its additive inverse, what will happen always?
You get 0.
You get 0. It's cancel each other out. You see it? So a number added to its additive inverse will always give you a 0. So I don't care what that number is. I can start with -10. What's the additive inverse of -10? Positive 10. And you take positive 10 and negative 10 together, it will always give you a 0. Questions on additive inverse? Okay, then move on to multiplicative inverse over here. Multiplicative inverse, another term for multiplicative inverse is reciprocal. You know what reciprocals are, right? So for instance, what is the reciprocal of 5? What do you have to do to find the reciprocal? Flip, right. Flip the numerator and the denominator, right? So 5 is going to become 1 over 5. And if you take the reciprocal times it by original number, what do you have? Always. Which is? Ooh, it's not equative. Watch what happens. If I have negative 6, what is the reciprocal of negative 6? Or should I say multiplicative inverse? Please understand the two terms are the same. What is the multiplicative inverse of negative 6? Negative 1 over 6. Notice I'm just flipping. I'm not changing the sign, right? If it's negative, it stays as a negative. So that would become negative 1 over 6, right? What is our answer now? 1. Look at our final answer. Exactly the same. So tell me, 2/3. What is the reciprocal of 2/3? 3 over 2. So if you take that times by the reciprocal, you always get back a 1. You see, for multiplicative inverse, that's how it is. That's how you recognize it to be a multiplicative inverse. Am I making myself clear?
Yes.
Okay, good. Here's another one. So we're moving right into what we call the equality property. And equality has four branches. Okay, first branch I want to talk to you about is called the reflexive branch. We call this the reflexive property of equality. Okay, reflexive, just like its name, a reflection of the number. So for example, if I have a 5 and I reflect it over my equal sign, guess what this number has to be? 5. That's how you recognize it. If I have 2 plus 3 over here, if I reflect it over, what do you expect to have on the other side? Well, it's not exactly like that, but it's 2 plus 3 also. It has to be identical, left, right. It has to be the same. That's what reflexive is. But notice that it stays under equality. Equality means equal. That means the left-hand side has to equal to the right-hand side. You see it? Okay? So in other words, a number will always equal to itself. That's a giveaway, isn't it? Okay. Another one I want to talk about is called the symmetric property. Once again, it still is under equality, so you will always expect the left-hand side to equal to the right-hand side. So for instance, if 3 plus 2 equals to 5, do we agree on that? Is 3 plus 2 equal to 5?
Yes.
Then can we conclude that 5, whoa, how did I write that in? Is the same thing as 3 plus 2?
Yes.
And that's what we call symmetric. But notice that symmetric, the left-hand side does not have to look identical to the right-hand side. However, if you evaluate both sides, the value should be the same because they're still under equality property. You see it? So for symmetric, so the main difference between a symmetric versus a reflexive is reflexive, the left has to look identical to the right. For symmetric, you don't have to have the identical numbers, but as long as the left equals to the right, you're fine. Is that clear? So to really simply put it, A plus B is the same thing as B plus A, right? It's perfectly normal, so that's symmetric. Any questions at all? Yes?
For reflexive, what if one says 8 plus 2 and the other side says 9 plus 1?
That's symmetric then. Is it? Then it falls under symmetric. Because symmetric, you can have two different things, but as long as you add up to be the same, you're okay. All right. Next one I want to talk about is called transitive. Crazy term. Transitive property. So what do I mean by transitive? For instance, if I have, let's see, 3 plus 2 equals to 5, okay? And 1 plus 4, I'm sorry, and 5 is equals to 1 plus 4. Do we agree on that? then can we conclude that 3 plus 2 is the same thing as 1 plus 4? So that's what we call transitive. So I'm not saying directly, but indirectly they're the same because they're linked up by a 5. See that? So when you see transitive, you will definitely recognize it right away because it has to have that same format, like three tiers. Like if this equal to that and this equal to that, then you conclude that. Okay? So that's what transitive looks like. Last one I want to talk about, still under equality, and that is called substitution. You've heard of this a lot actually, so it's not something that's new. But for example, if n equals to 5, okay, and you have 3n, then what does it mean? What do? You substitute it. So that means 3 times 5, right, equals to 15. So this is what we call a substitution property. I mean, you've done this all along, so it's not something that's new. Any questions at all? Okay, so I want to wrap our lesson up with one problem I want to work on with you right now. And this problem requires you to list out every single steps that's required to get the problem done. For example, I have 18 times 1 minus 3 times 2 plus 2 times 6 divided by 3 minus 2. So here's the problem. Okay. What's the first thing you want to do here? Parentheses. Very good. So I go straight into here, and I realize I have division and multiplications. I'm sorry, division and subtraction. Which one should I do first? Division. So I'm going to go ahead and circle that one right there and say I'm going to do that one first. So I end up with 18 times 1 minus 3 times 2 plus 2. 6 divided by 3 is? 2 minus 2 equals 2. Well, I'm not done yet. Notice I'm very tempted to get this done. However, for the purpose of showing step by step, please do it one operation at a time. So notice I get from 6 divided by 3 to get to 2. What property did I just use to get from here to here? Anyone want to comment on that? How do you get 6 divided by 3 to get that equal to 2? Okay. Do you recognize any other property? If you can't, mainly it's substitution. Okay, notice I substitute the 2 into 6 plus 3 in place of that. See? I replace that with 2. So I substitute it. Okay, next step, what do you do? Still instead of parentheses. So here it is again. Okay, I have 18 times 1 minus 3 times 2 plus 2. 2 minus 2 is? 0. But wait a minute. I think I learned that property before. 2, negative 2. What property is that? 2, negative 2. Get it 0 back. What is that called? Additive inverse. Thank you. This is the reason why I really wanted to take notes tonight, because otherwise you would not remember this. But you're right. Opposite of the numbers added together will always be a 0. So we call this additive identity. Oh, sorry. Additive inverse. Okay, next step. I have multiplication, 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 subtraction, addition. So, what do I do now? Multiplication from left to right, right? So 18 times 1 will give you 18, right there, minus 3 times 2. I'm just going to hold on for a moment. Notice I'm doing one operation at a time. How did I get from here to here? What property is that? A number times 1 is itself. Ooh, interesting. What property? What's that? Identity, but it's multiplicative. Real good. So you write multiplicative identity. Okay, does that make sense? Notice I go step by step, one operation at a time to identify every single property. Next step, what do you do? The 3 times 2. So 18 minus 6, right? But this has, I don't recognize anything. So in that case, if I don't recognize it, it's called substitution. Okay, next step. 2 times 0. 0. Ooh, I think I know that property. What is that? Yeah, multiplicative property of 0 or 0 product property. Either way, but let's name it multiplicative. My spelling's really bad. Sorry about that. Problem of 0. Okay, next one. What do I do now? 18 minus 6, which is 12. And what do we name that step? If you can't recognize the property, substitution. Thank you. Substitution. Okay? And then 12 plus 0 is? 12 plus 0 is 0. 12 plus 0 is? 12. What property is that? Additive identity.
Yes.
Thank you.
Got it. Finally.
Okay, does it make sense, people? What we're doing here? There's one problem right here. I basically asked to list out a lot of the properties that we've covered. And this is the kind of problem that I want you to work on tonight. I know it's going to take a lot of work. However, you know what? It's practice after all. Okay, any questions at all? If not, we are done.